For any process, either chemical or physical, when occurs spontaneously, there is a decrease of a free energy, and this decrease of free energy can be utilized to produce the electrical energy in the device which we call these electrochemical cells. So long I have discussed the different chemical reactions used in a chemical cells, and these chemical cells will provide the electrical energy from this decrease of free energy of this spontaneous chemical reactions. Today I shall discuss this another type. The physical process means the transport of a matter from one half shell to another half shell. If occurs spontaneously, then also the free energy will decrease, and this decrease in free energy may be utilized to produce this electrical energy in a device which we call this concentration cells. In concentration cells are of mainly two types. One is electrode concentration cell, and this electrode concentration cell, two identical electrodes of different concentration or pressure inserted into a common electrolyte solutions containing that ion of this electrode. And these electrode concentration cells will be of two types. Here the electrodes are the same. Electrodes are identical, only differing in concentration. They are dipped in a solutions containing the ion of that electrode. First I shall discuss this amalgam electrode concentration cell, and this is the amalgam electrode concentration cell, where the this cell contains these two electrodes of the same metal cadmium dissolved in mercury and forming this cadmium amalgam. And these two amalgams differing in concentrations, it is activity A1, it is activity A2, they are in contact with this common electrolyte called is here the cadmium sulfate, and these are platinum metals in order to contact these two half shells. And one example of this amalgam electrode I can put here. This cadmium, here platinum as the contact metal, and platinum contact metal, and here cadmium in amalgam, activity A1, and it is the common electrolyte cadmium sulfate solution, and here also cadmium amalgam, activity A2, and here the platinum electrode. This one is the positive electrode and this one is the negative electrode, or I can say this is the anode and this is the cathode. So whenever we are considering this type of amalgam electrode concentration cell, here in the left hand side the reaction, that there is oxidation reaction, and cadmium amalgam here A1, and giving this cadmium to flash solution flash to electrode, and it is the oxidation. And this right hand side, this cadmium ion in this solution taking these two electrons and giving this cadmium in amalgam and activity A. So this is the oxidation in this anode, this is the reduction, at this cathode. If we add these two electrode reactions, then we can have this cadmium amalgam A1 concentration and giving this cadmium amalgam at this activity A2. And naturally, to make this process spontaneous, this is the transport of this of the cadmium from the left to right. This A1 must be greater than A2 to make this process spontaneous. And if we consider this free energy change for this transport, then it will be 1 mole. So this is RT and ln A2 by A1. And this in this cell, this transport of this cadmium from left to right is utilized to produce this electrical energy. And here the 2 gram equivalent of cadmium is passing from left to right, and so it will be equal to minus 2F and E cell. If we equate this 2, then E cell will be equal to RT by twice F, and if we remove this minus, then ln A1 by A2. So this cell will produce this electrical energy so long A1 is greater than A2. When A1 is equal to A2, this cell potential becomes 0 and this cell will stop producing this electricity. And one thing I can mention here, the very small amount of electricity is drawn from this cell by means of potentiometer, and so this change is very infinitesimal amount, and these two amalgam electrodes are taken in large volume, so slight transfer of cadmium from left to right will not affect the values of A1 and A2, and these two will remain almost the same, and each cell will have a very steady value. Then another cell, another type of this amalgam electrode concentration cell, I can also write here this silver amalgam, here the platinum as the contact metal, and here the silver nitrate solution, and here the silver in amalgam and platinum. This one is the positive electrode and this one is the negative electrode. In this case, E cell will be equal to RT by F and ln. Here it is A1 and here it is A2, and so A1 by A2. Now I shall discuss of this head, this gas electrode concentration cell. Gas electrode concentration cell. Here the two electrodes are of gas, same gas, differing in pressures, and they are dipped in a solutions containing the ion of that gas. Here the hydrogen ion is the common ion which is reversible with both these electrodes, and these are the hydrogen, same gas. In this case also I can write this platinum and this hydrogen gas at P1 atmosphere pressure, and here this HCl solution and this hydrogen gas and P2 atmosphere pressure, and here also platinum, and this one is the positive electrode, and this one is the negative electrode. If we consider this type of gas electrode concentration cell, the electrodes are different, same electrodes but differing in pressures, and they are dipped in a solution of this hydrochloric acid, which contains the anion, which contains the ion of these two electrodes. Here the reaction is half H2 gas, P1 atmosphere, and giving this hydrogen ion solution plus 1 electron, and this is the oxidation. And in the right hand side, this hydrogen ion in solution plus 1 electron, and giving this hydrogen gas and P2 pressure, P2 atmosphere. So if, here it is a reduction, and if we combine these two, then half hydrogen gas at this pressure P1 atmosphere is moving to this side, half hydrogen gas and P2 atmosphere. So naturally this P1 must be greater than P2 to make this process spontaneous. So this for this spontaneous process, this delta G equal to half mole, so half RT and ln and P2 by P1. And whenever this free energy is converted into electrical energy by an arrangement of this type, then it will be equal to 1 electron is involved, so minus F and E cell. If we equate these two, then EMF of this cell will be RT divided by twice F and ln P1 by P2, and as I have said earlier, these two gases are taken in large amount so that minute change of this hydrogen gas from left to right will not affect this P1 and P2, and this EMF of these cells could be determined by means of potentiometer, which will draw very small amount of electricity from this cell. Another type of cell, another type of gas electrode cell I can also mention, this platinum and this chlorine and gas at P1 atmosphere, and here this may be taken this HCl solutions or another potassium chloride solutions which contains this chloride ion, and here this is Cl2 and gas and P2 atmosphere, and here this platinum as the contact metal, this one is the positive and this one is the negative. So here the reaction is oxidation, so Cl minus in solutions, giving this half chlorine gas P1 atmosphere plus electron, and it is the oxidation. And in this case, this half Cl2 and gas pressure P2 atmosphere and plus electron, and giving this Cl minus, and it is in solutions. Instead of hydrogen gas, here I can write this chlorine gas. So in this case, if we add these two, then half Cl2 and gas and P2 atmosphere is transferring to half chlorine, and it is the gas and P1 atmosphere. Here the gas is transferred from right to left, means P2 is greater than P1. P2 is greater than P1. So naturally this cell potential, this is in this case the cell potential will be equal to RT by twice F and ln, and here this P2 by P1 to make this cell potential is positive, and this cell will also continue to produce this electricity, provide this electricity so long this P2 remains greater than P1. When these two are same, this E cell becomes 0 and this cell will stop producing this electricity. Now I shall discuss the second type of a concentration cell, which is the electrolytic concentration cells. In these cells, electrodes are the same, but these electrodes are dipped in a solutions containing the solutions of the same electrolyte, differing in concentrations. These concentrations or activities are different. These are the two solutions, but these electrodes are same. This is the concentration cell. Here, this one will be this electrolyte concentration cell. Again, are of two types. One, the electrolyte concentration cells without transference. Without transference means without this salt, without this liquid junction potential. Without transference or without liquid junction potential. Without liquid junction. Here one salt bridge, this is one type, and I can write here this platinum and this hydrogen gas, 1 atmosphere. Here this HCl, phase boundary, and activity A1, and it is the salt bridge, double vertical lines, and this HCl and A2 activities. Here this hydrogen gas and 1 atmosphere, same, and here this platinum. So these electrodes are the same. They are dipped in a solutions, same electrolyte, solutions of the same electrolyte, but differing on activities A1 and A2. Here the salt bridge is inserted, and so the salt bridge will do not eliminate, but it will minimize this liquid junction potential. So if we write these electrode reactions and adding these two, we can get this cell reaction. And here this half hydrogen gas, 1 atmosphere, and giving this hydrogen ion in this left plus this electron, and it is the oxidation. And this right hand side, this hydrogen ion right, and taking this electron reduction, and a half hydrogen gas and 1 atmosphere, and it is the reduction. So this is the positive electrode, this is the negative electrode, this is the anode, and this is the cathode. Here occurs the oxidation, here occurs this half cell occurs this reduction. If we add this 2, then I shall get this H plus R, and it is H plus and L. Means a hydrogen ion is being transferred from right to left. So this right hand side hydrochloric acid concentrations or the activities is greater, means A2 is greater than A1. We can visualize in another way which one will be the greater, as the process is spontaneous. For the spontaneous reactions, all spontaneous reactions will try to attain this equilibrium. This is their motto, and to attain this equilibrium, they will also try to get this equalization of the concentrations, which is having higher value, that will be lowered down, and which will be lower value, and it will be it will try to get this higher value. This hydrogen gas is converted into hydrogen ion, and here the hydrogen ion is converted into hydrogen gas. Naturally, whenever the occurs spontaneously, this hydrogen ion is less in this hydrochloric acid, and this is why it is coming here, and this hydrogen ion is of higher concentration in this hydrochloric acid, and this is why this hydrogen ion is moving, is removing in the form of hydrogen gas. So this one will have, this hydrochloric acid will have the higher activity, and this hydrochloric acid will have this lower activity, and this is the spontaneous process. And so this free energy change for this process, I can write also this RT, 1 mole of this hydrogen gas is transferring, and ln, and this activity of hydrogen ion in this left divided by hydrogen ion, activity of hydrogen ion, and this right. Free energy is negative, means the free energy change is negative. This means free energy is decreasing. Whenever this free energy decrease is converted into electrical energy by this device, which we call the electrolyte concentration cell without transference, we can write 1 electron involved, so minus F, and E cell without liquid junction. So if we equate this one, then E cell without junction equal to RT by F, and this minus, if we remove, then it will be active ln. It will be ln activity of hydrogen ion, right upside down, and this activity of hydrogen ion left. But I have already told that this individual one type of activity of one type of ion is having not much practical relevancy. So instead of this one, we can write this mean ionic activity. So AH plus could be instead of AH plus, we shall write AH plus, and so and so here we can write this RT divided by F and ln. Here this A plus minus activity of hydrogen ion right divided by active A plus minus right divided by A plus minus left. And this A plus minus for this hydrochloric acid, it is giving this 2 ions also, so it is A to the power half. Mean ionic activity for this case of hydrochloric acid, it is the activity of hydrochloric acid to the power half. So it would be equal to RT and twice F and ln A right hand side A2, so A2 by A1, and this is the potential or EMF of the cell without liquid junction. One thing I can mention also, as this hydrogen ion is passing from right to left, here this hydrogen ion is decreasing. Here the hydrogen ion is decreasing, here the hydrogen ion is increasing. So compensate this electron neutrality of these 2 half cells, this potassium chloride of this salt bridge, here the right hand side hydrogen ion is produced. So here the chloride ion is coming from this salt bridge. Here this potassium ion is coming from this salt bridge in order to make both sides electrically neutral. However, I can say the by means of potentiometer, when we are determining this cell potential, this infinitesimal amount of electricity have been drawn, so the change will be very, very small, infinitesimal change, and this change will not affect this A1 and A2 again. And also another fact is that these two solutions have been taken in large amount, so this effect is not so prominent. Another cell of this type, another example I can write here, this one, and here this silver, and this silver chloride and solid, here HCl, and this A1, and double vertical line means insertions of this salt bridge to minimize this liquid junction potential, and here this silver chloride S, and here this silver, and this one is the cathode, and this one is the anode. In this case, this reaction in the left hand side, oxidation, and this oxidation will be like that: silver plus silver solid plus a chloride ion from these solutions. This left will give this silver chloride solid plus 1 electron, and this is the oxidation. And in this case, this silver chloride solid and taking this electron, there is a reduction, and so this silver metal plus chloride on and to this right, and this is the reduction. So the net cell reaction, if we do it Cl minus left and to Cl minus and right, means this hydrochloric acid, is having the higher concentration A1 greater than A2, higher concentration or higher activity than this one, in order to make this process spontaneous. And in this case also I can remember this fact here: this chloride ion is coming to this one, and this one is coming this patients. So this one must be the higher value, and this is why this chloride ion is removed for this spontaneous process to make equilibrations of this concentration. And here the hydrochloric acid is less, so silver chloride is giving this chloride ion to this half shell. So this E cell, in the same fashion, if we do this without junction, this will be equal to RT by twice F, and this will be like that. And ln, here this side, this one is more higher, this A1 will be A2, A1. This will be the expressions of this type EMF, of this type of electrolyte concentration cells. So far I have already discussed the two types of electrolyte concentration cells, where the salt bridges are used to minimize this liquid junction potential. So far we have used to construct this electrolyte cell without transference or without liquid junction. Salt bridges have been inserted, and I have already told the salt bridge cannot totally eliminate the liquid junction potential, but it will minimize to 1 millivolt to 2 millivolt liquid junction potential. So if we like to totally eliminate this liquid junction potential, then these two electrolytic solutions will not be allowed to make a junction in this concentration cells. This is this type of concentration cell. I can also write here: this is a hydrogen, and this is a hydrogen electrode and hydrochloric acid, activity A1, and this is silver chloride and silver chloride, and this one. This type of cell have been given a sketch, and in this case, this hydrochloric acid have no chance to make a junction, and so junction potential is totally eliminated. this type of cell is also very popular. In this case, it is the combination of these two cells. Two cells are connected in series. This is negative electrode and this is the positive electrode. Actually, up to this one, this is negative, this is positive, this is negative, and this is positive. So these two cells are constructed in series. So the cell reactions, left hand side cell reaction this one, right hand side cell reaction this one, and cell reactions will also be added up. Whenever these two cell reactions are being added up, cancelling these like terms, we get this hydrochloric acid from activity A2 and transferring to the hydrochloric acid to this activity A1. Means hydrochloric acid, 1 mole of this hydrochloric acid transported from right to left if 1 Faraday electricity have been drawn. So naturally this A2 must be greater than A1 to make this process spontaneous, and this E cell without junction is equal to actually RT by F, 1 Faraday. Electricity is drawn and it is ln simply A2 by A1. And this is another example I can also show for this type, say zinc, and here zinc chloride solutions A1, and here this silver chloride solid, and here this silver, and it is the silver chloride solid, and here zinc chloride zinc chloride activity A2, and here this zinc, and this is the positive electrode and this is the negative electrode. Instead of hydrogen electrodes, so we are replacing this zinc on electrodes. And in this case also, the 2 Faraday's electricity have to be drawn. 2 electrons will be involved in this electrode reactions. So this will be this E cell without junction equal to RT by twice F, and this ln. Here also this A2 will be greater than A1. A2 will be greater than A1 in a similar fashion. General expressions is that general expressions of this type, general expression of this type of EMF, we can write this E cell without junction equal to nu RT and divided by NF, and it is ln mean ionic activity 2 and mean ionic activity 1. So in this case, the total number of ions coming from the dissociations of this zinc chloride. So in this case, nu will be 3 and 2 Faraday, and it is n equal to 2, and so it will be 3 RT divided by twice F and ln A plus minus 2 and divided by A plus minus 1. And this 3 whenever coming to this power, and this will be this RT by twice F and ln A2 by A1. As for the zinc chloride, for activity of this zinc chloride, we can write this plus minus to the power 3. So this is all about this electrolyte concentration cell without a transference. Now in this head I shall discuss the electrolyte concentration cell with transference, means with liquid junction, and this some typical cell of this type is hydrogen electrode, HCl activity A1 and HCl activity A2. These two are the differing in concentration activities, same electrolyte. Here the one cell membrane or this porous barrier have been inserted so that this ion can pass through this junction, and at this junction some junction potential is developed, and already I have discussed the magnitude of this junction potential. And here these electrodes are the same, and this is the sketch of this shell. Here the porous barrier or this cell membrane used to separate these two solutions to the same solutions, same electrolytes, two solutions of the same electrolyte differing in activities. If we write this, if we try to formulate the EMF of this shell, then we may consider all these electrode reactions. The electrode reactions are this anode, electrode reactions are this cathode, and also the transport through this cell membrane. Here actually this half hydrogen gas electrode reactions, 1 atmosphere, and giving this hydrogen ion in this left plus electron, and here this oxidation. And this right hand side, this hydrogen ion, this right hand side hydrogen ions from this hydrochloric acid in the right hand side, taking this electron in this reductions and giving this hydrogen gas, and it is also 1 atmosphere, and it is the reduction. And this shell in this junction here, if we draw 1 Faraday electricity from this shell, then suppose 1 Faraday electricity we are withdrawing from such type of cell, then 1 gram equivalent of hydrogen ion is coming to this left hand side, and out of this one T plus gram equivalent of this hydrogen gas from this hydrogen ion from this left will go to this right hand side, hydrogen ion, and this right hand side, T plus the transport number of this hydrogen ion. And here the 1 gram equivalent hydrogen ion is being removed, so 1 gram equivalent chloride ion remaining in excess, so it will be T minus, and this chloride ion and this right to it will move to this T minus. And already I have told earlier that whenever the 1 Faraday negative charge is transferring from this negative electrode to this is negative electrode, this is negative electrode to this positive electrode through this metal wave, then 1 Faraday negative charge will also be transported through this junction. Here this here T plus positive T plus Faraday of positive charge is carried by this hydrogen ion from left to right. It is equivalent to T plus Faraday of this negative charge is transferred from right to left, and T minus Faraday of negative charge is carried by this chloride ions from right to left. So T plus T minus, it is equal to 1 Faraday. Both sides, 1 Faraday is coming outer circuit and 1 Faraday coming this inner circuit to complete this circuit. Not only that, by doing this, each half cell becomes electrically neutral. If we add all these three, 1, 2, and this transport, then it will be like terms we can cancel. 1 minus T plus into this hydrogen ion, and this right plus T minus chloride ion right, and giving this T 1 minus T plus this hydrogen ion left plus T minus chloride ion and left. This transfer will occur cancelling this like terms. And this one is the 1 minus T plus means T minus hydrogen ion right, T minus chloride ion right. We can write this T minus hydrochloric acid right, and giving this T minus hydrochloric acid to this left. So actually right hand side, this A2 must be greater than A1 to make this transfer spontaneous. And again I have told earlier that whenever we are drawing this electricity from this cell by means of EMF of the cell by means of potentiometer, a minute amount of electricity have been drawn, and so this transfer will also be infinitesimally small. Not only that, these two volume of these two half cells are taken in large amount in order to prevent any change of this A1 and A2 for these two half cells. And if we consider then free energy change for this transport will be T minus RT, and this ln activity of this left hand side, activity of hydrolysis left hand side means A1 divided by A2, and this one equal to 1 Faraday electricity have been drawn, so minus F and E cell with a junction. So equating this to 1 is this 2 is cell with junction equal to T minus RT by F, and ln of A2 negative sign I like to remove, so A2 will go upside and A1 and this one is the expressions of this EMF of this cell with the liquid junction for this cell. So actually what happens, it is very interesting. These electrodes are reversible with this cation, and the transport number of this anion is coming to this expression. So one thing I can say, the expressions of this EMF of the cell with the junction will contain the transport number of the ion other than 1 with respect to which this electrodes are reversible. If the electrodes are reversible with the cations, then anion transport number will be coming up. Another example of this type of cells I can also mention here. Another type, say here silver chloride solid, and here this HCl and A1, and it is the cell membrane, and this HCl and A2 and silver chloride solid, and this is a silver. So this is a positive electrode and this is negative electrode, similar type. This one, instead of hydrogen electrodes, silver chloride electrodes have been given. And in this case here, actually the 0.1 Faraday electricity have been drawn. So this electrode silver plus chloride on in this left, and giving this silver chloride solid plus electron, and this is oxidation. So this electrode is reversible with the chloride ion, and in this case also silver chloride solid and plus electron, and giving this silver plus chloride ion to this light. So and there will be transport of this ions through this junction, and here this chloride ion is removed, so hydrogen ion T plus hydrogen ion left, and giving this T plus hydrogen ion right, and here this chloride ion is remaining excess, so T minus chloride ion from this right to go to this T minus chloride ion this right. And if we add all these forms, then it will be the HCl adding these two electrode reactions and transport through this cell membrane, it will be this A2 A2 and A shell A1, and A2 must be greater than A1. A2 must be greater than A1. This can be also shown here. The chloride ion is depleted, and this chloride ion here deposited, and this chloride ion here, this chloride ion is coming to this one from this chloride. So this one must have this hard value, and this is why this one actually removed. This one is the removed. So A1 must be greater than
T plus.
A1 must be, this hydrochloric acid must have the hard concentration. This is why this chloride ion is being removed, and this hydrochloric acid having the lower activity, and this is why the chloride ion is coming here. So A1 must be greater than A2, and the cell potential with the junction will be equal to T plus the transport number of the hydrogen ions, and here the RT by F, and this ln A1 by A2, and this is very fantastic. That this cell potential with junction and cell potential without junction, if we consider, then transport number of this of the ion could also be determined by this EMF and measurement. I shall discuss later on how this transport number could be measured by using the cell potential with junction and without junctions. Another electrode, another cell of this type, another example, I can say lead and lead sulfate solid, and here the copper sulfate A1, and here the cell membrane and copper sulfate and A2, and here this lead sulfate solid, and here also lead, and this is positive and this will be negative, similar to this one. And in this case E cell will be equal to this T plus means transport number of the copper ion, and RT by twice F, and ln A1 by A2. So this is all about the transfer, all about these concentration cells. I have tried to discuss it more elaborately, more fully, taking all sorts of considerations, and the next day I shall try to explain or categorize the applications of try to explain the applications of this EMF measurement. How many properties, how many could be determined by measuring the only property, which is the EMF of this cell, and EMF of the cell will be connected with the various properties, and by measuring this EMF of the cell by means of potentiometer, other properties could also be calculated. Thanks to you all who are watching this video. It is rather a boring job for you to follow up such a long video records, and I hope this sort of discussion will help the students, especially for the chemistry students in their examinations. Thanks.